Good day. Today is the Numpy and matplotlib third part of the lecture. First, we go for the difference between flatten and ravel in Numpy. So the C-like index, like C language like index, whenever we use it flatten, then it will go like this, row-wise. And when the Fortran-like index in the flatten or ravel function, it will go for this column-wise. This C stands for row-wise, C-like, or F stands for column-wise, like Fortran. Then we'll discuss the plot and subplot. This is scatter plot, three-dimensional. This is 3D bar graph, bar chart, and this is stack plot. And this is how you can make a. This is one of the complex diagram, and you can annotation. You can make this diagram. This is a particular. This one is particular a plot, and you can how much in annotation with this is an example. Firstly, the difference between flatten and ravel. So here we see that flatten, it basically create a copy. It is called by value concept. It doesn't put the original thing into this. So we can see it here. This is a concept, this is a print array. We can distinctly see here that is import numpy, and here with the ravel, array ravel, and ravel, you can see the 99 is different. So ravel is a call by reference sort of thing. If you do it ravel, it automatically change. But the flatten, if you make it a flatten 099, the print array will not change, because that will be in the flatten will take a separate copy to it. So definitely ravel will be faster. This is the C-like, it is a row-wise, C language-like, and this is the, in both the cases, in flatten and ravel, this is the convention, F for column-wise, or Fortran-like. Like it here, you can see it, that is 1, 2, 3, 4, this is NP array, it will like this, and the built-in, if you say the 2 to 4 and order 8, this will be like this. In matplotlib, you can have two subplot by this 2 or more plot subplot, and you can put it by sine curve here, and here is the cos curve. So we can put it in one curve, or in a single we have to make a subplot also. And ultimately plot.show will show the both the subplots. 2D scatter plot, and this is 3D scatter plot. 3D scatter plot, the beauty of it is with the various data, you can point out where is the outlier. So you can find the outlier data by this scatter plot. This is 3D bar chart with this program. You can do 3D bar chart like 3D scatter plot. This 3D bar chart. The histogram I already shown. This is a diagram. It's a raw data. The histogram, and another is cumulative histogram. So all these things, cumulative histogram, it is first is raw data, and this is the histogram, and this is cumulative. So cumulative, so that it shows like this. This is a quadratic function. The function is like x squared minus 5x plus 6. You can visualize it by matplotlib. One can visualize. There is a stack plot. You can see the red, green, blue, and the values are given here. And we plot it in red, green, blue, and the stack plot. We can see what's the contribution of blue, green, and red. Ultimately, we can make a plot with so much annotation. With this, so many coding, you can put it in matplotlib. So thank you for viewing.